At this point, let me invite Miss Alyssa Gibbons. She is an architect she's LEED accredited, and she is going to present us her presentation on green building architectural design.
Hi, everyone. I don't know your name, but thank you for introducing me. My name is Alyssa Amour, and I actually have a background in structural engineering. That's where I started studying at university, but I decided to do architecture at the same time. So, yes, high capacity for stress. And I ended up falling in love with architecture just a bit more than engineering, of course. I am quite logical, but I am quite creative. And I found that architecture kind of gave me the opportunity to solve problems in not just that more technical way, but still give me the freedom to express a bit more and engage with clients. So just for my benefit, are there any other designers in the room? Okay, architectural designers. By show of hands? 1, 2. Okay, so I'm gonna try to not desperately cling to y'all with eye contact in a room full of engineers, because usually we end up fighting. When I was first asked to present, I didn't know where to take it. Should I talk from a technical point of view, with a lot of my work in building information modeling and the more digital aspects? Should I speak from the sustainability advisory point of view that I do in terms of LEED and WELL accreditations? But I thought I would speak from the heart, cliched architect, and speak to you from a more human point of view, because I found throughout my career so far that authenticity wins, passion for design wins, and at the most basic level of what we do in the built environment industry is about providing safety, one of the most basic human needs, shelter, and space for human engagement. So, with that said, I'm going to talk to you about sustainability by design, but also a bit about structural resilience. And I'm not sure how many of you are not from Barbados, but I'll start with a bit of a history lesson that most of us probably have seen plenty of times before, and then tie that into what became one of my favorite projects that I've worked on so far in my career. So, before I do that, let's start with what I think is the first rule of sustainability, which is to align with natural forces, or at least not try to defy them, which should be basic common sense. And most of us in the room should know what a chattel house is, but if there's no one that does, raise your hands. Okay, a few people. So, in this kind of unsure climate we're in now when it comes to climate change, one of the simplest things you can do is to figure out what worked before. How did we survive to this point? And take a look back in history at some of the early typologies that managed to survive, or at least not completely shackle out, for lack of a better word. And some of the earliest examples we have of these on the island are chattel houses. And originally, I think we all in the room are aware of slavery, etc., etc. But what these houses represent to me is the absolute resilience of Caribbean people by nature. Faced with excruciating circumstances, they found a way to simply survive, right? Originally, these chattel houses had this kind of conundrum that they had to deal with, obviously. They needed to withstand hurricanes, tropical weather, but in many circumstances, after the abolition of slavery, they needed to be movable. It's one of the earliest typologies of movable tiny home. You needed to be able to call a friend and pack up and leave if you were in danger. So how do you marry resilience and robustness against weather, but still have that kind of flat pack mentality and ability to move at a moment's notice? Well, as many of us probably know, the answer lies in the arrangement of the timber facade, with windows and door openings and louvered apertures that allowed wind to actually enter the building. So by arranging these openings in a symmetrical way, you'd literally be able to open up the house to the elements and allow the strong forces of the wind to pass through. So, like I said originally, it's about not trying to define nature, and in many cases where they simply didn't have resources to withstand nature, they simply made some compromises and allowed nature to enter. And this is kind of the result that you get in instances where buildings ended up failing. They failed in ways that were recoverable for them at the time. Like I said, in many instances, houses simply didn't shackle out or get let down, for lack of a better word, but they were done in a way that people could recover the materials. And I always found this fascinating because it's about bending but not breaking. So if that ability to work with nature rather than against it is the first rule of sustainability, then what is the second? And I think for us in a Caribbean context, we cannot have this conversation of green architecture or green design or sustainable design without including resilience. And I think for us in a hurricane-prone area, sustainability and resilience really do mean the same thing. Case in point, drawing on these principles as a designer, doing your precedent studies, your research, there are opportunities that pop up where you get to integrate some of these design principles and understanding. This is a project that I'm going to talk to you about, probably my favorite project I've ever worked on, and is located in Dominica. I think when we think about green and sustainable, this is what we think about: flora, fauna, beautiful imagery of Earth at its best, but we also need to design for Earth at its worst. So following on from, I think Ms. Alara mentioned Hurricane Maria in 2017, I was working in St. Kitts at the time, and there were a couple hurricanes in the area at the time. Working on St. Kitts, we got affected by one of them, and a lot of the islands around us were flattened, but luckily we were safe. And I got the call from the director of the company that I was working with at the time about a client in Dominica that had suffered devastating damage to his property. So I probably had a couple of days' notice to get on a plane and go down and try to assist. So I did that, and this is an aerial image of one of the housing types on the land that was totally destroyed by the hurricane. So when I got there, I dived right in on site with the structural engineers, with the client, with the contractors, trying to understand what they needed, what didn't work, and how do we reimagine this space into something that could withstand another hurricane like that one. I think this could have been done digitally. This could have been done with drone and aerial imagery. This could have been done with LiDAR to understand the rock face of the site and the tectonics of the area. But there's always that human aspect that you cannot digitize. So it was super important to go there and have the conversations on site with people with local knowledge and kind of build a solution from that. So some of these images here are just simple sketches literally done on site, either using somebody's helmet to press on, palm of your hand to sketch out ideas on site, alongside the client, alongside the structural engineer. Just coming up with ideas of how do we integrate simple design principles that are low tech, that the guys on site, the survivors of the area, can integrate into their architecture moving forward. So, Sing Sing Restaurant and Gomier Spa were two interventions that I led. Super simple, based on those ideas that we learned about traditional vernacular, this idea of letting wind into the building if you don't have the resources to shore yourself up against it. We came up with this idea of what we call a sacrificial core. So in this building at the top level, we're talking about Sing Sing Restaurant here, we came up with the idea of having these two lockdown zones that were both watertight, structurally sound, and allowing the central core of the building that you see on the image to the right to take wind through the building in the event of high wind. So In the event of a hurricane, for example, the client would be able to take all of the furniture, place them into those lockdown zones, and bunker in the ground floor area that you see there that would be kitted out with cold storage, bathroom facilities, etc. I think one of the things that is becoming more prevalent now is lack of warning. I mean, just last year, July, I believe it was, we had that freak storm where we lost almost 2,000 homes and we had no warning. So this ability to integrate resilience measures into simple buildings so that people can shelter in place is super critical. Here we go. And in true architectural form, just some pretty pictures. But you can start to see here how we solve some of these issues with, on the ground floor, we had 2 cantilevered beams into columns. So it was kind of a 4-beam configuration coming into 2 columns, and the entire building cantilevered around that platform, with then areas that jutted out into the surrounding tree canopy. And then in terms of air quality, natural ventilation, passive cooling, integrating that louvered element into the central core of the building so that as wind passed through, it had plenty of opportunity to get through the building, up and out of the building for cooling as well. And similarly, the spa building, the client really wanted to integrate some amenity spaces throughout the resort. So again, we ended up walking the site with the structural engineer, choosing a location based on their knowledge of the rock face, examining, designing, pinning the structure back to the rock, and designing a simple cantilever solution. This was not about doing something super beautiful or pretty or stroking anyone's ego. It was about giving a tight footprint, something that worked and was elegant but still restrained. Again, some more internal imagery, but you can start to see the solution at the bottom where we cut into the rock. Again, simple cantilever solution, and those 2 bunker spaces off to the top and bottom on the image on the far right, the drawing on the far right, those bunker spaces that allowed the client to store away any massage tables or any amenities, and bunker space at the bottom if they did have some kind of high wind gust or high rain and needed to shelter in place. Speaking more about materiality, I think something that goes untalked about sometimes in terms of the greenness of a building is how do we tackle that issue through use of materiality. Obviously, after the hurricane, there were a lot of fell trees, and we wanted to reuse them in some way, whether it be for cladded elements, structural elements, or simple furnishings within the space. So we ended up using some of the timber for cladding. We used it for bar tops and even the hostess station within the restaurant. And that in itself was an interesting exercise, climbing on top of these big trees and directing people exactly where to cut, people offering you things to smoke, and you trying to do your job. And this is what you come up with. Again, it was not about creating this gem of a building or icon of a building in the middle of a Dominican forest. It was about tastefully taking elements that were around us in a low-tech way, that we could pull the Rastaman linemen on site and get them to help us to integrate these things into the building. And I'm proud to say this ended up being an award-winning piece of architecture with the company that I was working with. And I think this is why it's one of my favorite projects so far, because it was so intimate in scale and quite beautiful in the end, I think. What you see there are these timber fins that shoot over the glass of the windows in the building. Intentionally done to allow light to penetrate into key areas like display kitchen spaces, but also help to protect the glass from wind-driven missiles as well. It also helped to kind of break up some of the wind force against the building, so it never gets enough purchase to totally knock the building over. And this kind of approach of taking traditional typologies and applying them to slightly more modern designs is not obviously something that is unique to Barbados. We do it throughout the Caribbean, from Trinidad, South and Central America, dealing with flooding and landslides and elevating structures on stilts. And obviously addressing issues like seismic activity. And the gingerbread houses in Haiti is a great example of this. I always love this image because this sketch is not mine, can't take credit, but it is a PBS special where they ask kids to sketch what they thought a house should look like if it was meant to stand up from a hurricane or an earthquake. And a kid did this. And if it must have been a Haitian American kid, a kid did this. And if at a basic level we understand what it takes to not fail, I think as qualified engineers, architectural designers, we should be able to do the same. Now, I've spoken from a very analog point of view, but a lot of my work is digital as well. A lot of, well, we used to call it building information management or modeling, but it's really digital twin construction, where you literally, instead of discretizing elements, you literally create a virtual twin of the building in virtual reality. And I can't stress enough how important this has become to my job, because what it allows me to do is test. Test in an environment where there's no loss of human life, where there's no damage to critical infrastructure. It allows me to fail, tweak, optimize a building till I get it right, or as close to right as I think it can be. And within that virtual environment, you can then start to run simulations for disaster preparedness, run simulations for Category 5 hurricanes. No, we're not God, but a lot of my work to date has been about attempting to take the guesswork out of building performance. I, as a designer, quite frankly, could care less about how pretty a building is if it doesn't perform. But it helps if it looks good. We're at a point now as well where it's not just about the aesthetics of the building or the structural performance, but also the energy analysis. So having that digital twin, I can apply metadata to each element so that I know the carbon footprint of it, the embodied carbon. I know the energy performance. I know the specification of the materials, whether it's a phase change material, how it performs under different radiant exposure. And the added value of that is I can do trade-off analysis. So as a client, you might say to me, I don't care about daylight in my office space, which is a poor stance to have. But if you decided to do a cost analysis of that versus, say, the sizing of your HVAC system or the sizing of your PV array on the roof, then we can make really informed decisions and decide where do we want to spend money, where we're okay with paring back, and decide what we want the final performance of the building to be. Coordination and clash detection is another huge benefit of digital twin construction, because rather than having arguments about where to put the stairs or where to put the columns and beams, preferably not in the landing, which is conversations I've had before with lovely people such as yourself, we could see these real time in 3D at a meeting, not waste a lot of time arguing about what should be simple things, and make a decision. Move the column or not, move the stairs maybe, but actually decide where do we want to put our openings. Make sure that the MEP conduits, pipes, sewage is not running through what's supposed to be a structural column. And then I don't have contractors on site cutting holes in what makes a building stand up. Yeah, so I talked a little bit about some of the simulations that we can run, but they're infinite. Cost analysis is important, but I think where the future of the industry right now, the trends that I'm seeing is definitely in decarbonization. I think we're still having conversations about sustainability, energy efficiency, building performance, but I think decarbonization is becoming super critical to the conversations, not just for architects, but engineers as well. And you can see why. If you look at the embodied carbon of building elements, structure and support structure actually takes up quite a bit of that. We can design a building to death. We can kit it out with PV. We can fool ourselves into thinking that we're being energy efficient, but it's about reduce, reuse, recycle is the reduce part. We talk a lot about net zero, but if you're overusing and overcompensating, that's still net zero, right? You need to reduce first, be as efficient as you can first, and a lot of that comes from something as simple as orientating the building in the correct way. And that conversation happens between architects, engineers, client, at the initial design charrette, hopefully where everyone is sat together thinking about how to make this holistically the best building possible. So on the left there, you can see a typical example of how we would visualize a structure. So again, it's not just about what it looks like, but what are those elements doing? It's not just about where is your concrete coming from, but where are the materials extracted from? All of that goes into the carbon embodiment of each element within the building. So I think without us working together, without us working both analog and digitally, we will not get to that point where we can say with confidence or be able to hang our hats on the fact that this building is designed in this way, has this specific footprint, or is expected or predicted to perform in this way in certain environments. So I hope that moving forward, it would not just be on the onus of the architects to get as digital as we can, but on the entire design team, because I think that's really the only way that we will be able to, I don't want to say get to net zero, but design with the best outcome in mind. And I think that's it. Oh, one more. But yes, I think just tying it back into what I said earlier, we've been on Earth for quite some time, and we've survived as a species to this point. That's not always by luck, it's by intention. We know, for the most part, what has worked for us before. We see it in our culture, we have examples of it. And I think as we look towards this uncertain future, we need to design with the past in mind, and design not just hoping for the best, but based on, our past experiences, designing for the absolute worst. Thank you.
Thank you. Thank you so much, Ms. Gibbons. That really was a great presentation.